Hi everyone, I am Mashfiqui Rabbi. I am a research assistant at Apple. Today I'll be presenting an app called ReVibe. This work is done with my colleagues at Harvard and University of Michigan. Let me start by giving an overview of what is ReVibe. ReVibe is a mobile app to recall earlier moments of the day in the evening, and ReVibe provides context from these earlier moments to make the recall easier. The idea is rather than interrupting people with ecological momentary assessments or EMAs, and asking how they're feeling, like for example, in the middle of the day. ReVibe uses a less interruptive method where we ask people to recall in the evening what they were feeling, for example, in the midday. And we use context such as location and activity from midday to improve the recall of what they're feeling on the midday. Now, the question is, why would anyone be interested in something like ReVibe? As you may know, mHealth app have very poor engagement. A recent market research shows that 74% health app users stop using the app after their 10th use. Now, the key word here is use. When you ask people for more than use and interrupt them with EMS, then they would disengage even more. But despite this highly interruptive, EMS are still widely used, and they are still the gold standard for in-the-moment data collection because they can capture subjective data and they are highly accurate, because people reply in the moment as things are happening in their life. Now, given the advantages of EMAs, people are trying to improve adherence of in-the-moment data collection for a while. The most common approaches are motivating people with money or gamification. But where ReVibe is different is rather than motivating people, ReVibe uses a different mechanism, namely reducing burden to improve adherence of the collection of data for daily moments. And the reason why ReVibe is low burden is quite obvious. Rather than pinging people 4 times a day and using EMS to ask people what they're feeling, ReVibe automatically records context throughout the day and does not ping people. And at the end of the day, when people are less busy, ReVibe asks about moments earlier in the day and uses context it recorded earlier and to improve recall. And literature human episodic memory shows that when people are presented with context, they recall better. But those studies were in controlled settings, so we expanded the idea in uncontrolled setting, where we continuously recorded location, physical activity, and whether there is human conversation present nearby. And in the evening, we asked people to recall like moments earlier in the day. For example, in this picture, moments 11 a.m. Earlier in the day. And we present location, activity, and ambient sound 15 minutes prior to 15 minutes after 11 a.m. And then we ask question what is happening around 11. And the question we asked, what was the participant stress, mood, what they were doing, like who they are with, and some standard questions around mindfulness and sensitive questions. But before we go to our user study, I want to mention that there is one other low burden method in the literature called micro EMA, but micro EMA ask one question at a time and their adherence is quite high. But often scientists are interested to ask multiple questions to capture latent variables or find interrelationship between variables. For example, they may be interested in whether stress is related to hopefulness. So if scientists want to ask like multiple questions, then micro EMA has to ping multiple times. And if we consider that what is the adherence of all these questions together, then the adherence is 10.9. Moving on to the evaluation study. So far, we have made the assumption that ReVibe has better adherence than EMA and context can improve recall accuracy. We explicitly checked these assumptions in our evaluation study. Specifically, our first hypothesis is accuracy of recall will be better when context is available. We measure accuracy of recall with EMA at the same moment as commonly done in recall studies. Our second hypothesis is evening recall has better adherence than EMAs. We ran a micro-randomized trial to test these hypotheses. The study goes as follows. At the start of the study, participants sets up a time they wake up. We denote this time as TW in the figure. From TW, we define 4 adjacent 3-hour non-overlapping window. And within each window, we select a time point at random, which we call decision point. We decide with 0.5 probability whether to ask an EMA or not at a decision point. In figure, we denote a solid circle if we asked an EMA at a decision point and a hollow circle otherwise. At the end of the day, in the evening, denoted by TR in the slide, we randomly pick 2 of the 4 decision points and ask participants to recall these moments. One of these 2 decision points is randomized to receive contextual information. We denote the recall with context with an asterisk in the figure. And this process repeats for 14 days for each participant, and 14 days is the length of our study, and we have in total total 54 participants. Moving on to the results of the study, we found our first hypothesis to be statistically significant. Concretely, recall and EMA answers exactly match with each other 5.6% more when contextual information is available during recall. We also found that decision points from the afternoons are easier to recall than morning, which makes sense since afternoon is more recent when recall happens in the evening. We also found our second hypothesis to be statistically significant as well. Evening recall adherence is nearly 27% higher than EMAs. This is a large effect for behavioral studies. We also found that EMA adherence decreased over study days, but recall accuracy did not significantly decrease over study days. We also ran some exploratory and qualitative analysis. Our first exploratory finding was raw accuracy of recalls are indeed quite high. For binary questions, we found that more than 85% cases, recall and EMA answer exactly match with each other. For 5-point Likert scale question, more than 86% cases, recall and EMA answers are within 1 point of each other. Another exploratory finding was EMA adherence is lower for morning moments compared to afternoon. No such time of day difference exists for recall. Finally, we found that interruption burden of EMAs is indeed higher than evening recall in the user burden scale, but a surprising finding was participants felt more self-reflective during evening recall compared to EMAs. With that, I will end my talk, and please, you can ask me question using my Twitter handle. Thank you.